main thing I want to say here, and I'm kind of the host, if you will, and I just want to say thank you for joining this. This is a monumental moment for us to be able to present to you with Google directly. It's a really cool time for us because Barry just comes from a unique perspective where he's really working to optimize those Core Web Vitals and help you figure out how to. So that's our message as well, and the two of us get to come together and really just help you go through the Core Web Vitals. So a little bit of housekeeping first. Session is being recorded, so you'll be able to get the recording. You'll be able to send it out to colleagues that weren't able to make it, whatever it may be. We're going to have Q&A at the end of this so that we can go ahead and ask questions and engage and be able to figure out what this means for your space. Now, some questions might be very specific to your customer world, and if that's the case, we might sidebar that and then create an offline chat where we can talk through things and feel free to still ask those questions, how to apply it to your specific area, whatever it may be. But we just wanted to make sure to format this in a way that can be very engaging for you. So the general learnings, I'm not going to just read this, that's very boring, but basically what you're going to be able to do is understand why Core Web Vitals matter in the first place. And really the big message here from our standpoint is we're all about friction quantified. Now, friction quantified is being able to take what's happening in your digital space and being able to figure out where that comes together to create the best customer experience. Now, if you attended our previous trainings on championing business analytics, then you'll know some of those conversion rate curves and how to understand those conversion rate curves. If you didn't participate in that one, I highly encourage you to go look at that one. It was hosted by yours truly. And I really, really love that topic. But when we start getting into understanding what we can do about it, that's when we start using these Core Web Vitals and more importantly, get into the details of what Core Web Vitals can do for us. And that's what Barry's here to talk about. And with that, I would like to go through some intros. Barry, if you'd like to introduce yourself, that would be great.
Hi, everyone. I'm Barry Pollard. I don't work for Blue Triangle. But I'm very happy to come along today and give a bit of background on the Core Web Vitals, a bit of information. We work with a lot of the run providers, including Blue Triangle. I've got a sneak preview, a glimpse of what they've done here, and it's very much in line with what we're hoping people are doing and how we see the best ways of being able to address your Core Web Vitals. So I'm excited to see what you guys all think of it. Kerrion, sorry, I'll pass off to you. I forgot the magic words.
No problem. Thanks, Harry. Hi, I'm Kerrion Burton-Evans. I work within the sales engineering group at Blue Triangle, and I'm the director of technology. I've been with the company about 18 months, and prior to that, I spent 8 years in the CDN space in sales engineering, and then 15 years in solution and product architecture in the telco, OSS, and BSS space. My main passion and area of focus in the organization is innovation for our platform, which is why I'm very excited about what we're going to talk about today. Back to you, Nick.
Yep, and I'm Nick Paladino. I've been with Blue Triangle about 2 years, but it doesn't feel like that because I was a customer before that, both as a site reliability engineer and as a product manager. So I like to use that experience to help customers be able to champion a lot of these different areas. So as we go ahead and get into this, I'm going to go ahead and pass it over to Barry so he can start the presentation and we can get rolling.
I'm here to talk about a little bit and give a little bit of background on Core Web Vitals. To do that, I'm presuming most of this audience will have heard of Core Web Vitals, but I think it's worth recapping quickly what they are. So the Core Web Vitals are a set of 3 metrics measuring 3 different things that we think are the best ways of measuring user experience on a page. So we have 3 metrics, largest contentful paint, or LCP. That's when, as the name suggests, the largest piece of content has been drawn to the page. Typically, that's a banner image, maybe your H1, and we're using that as a proxy metric for the page is now mostly loaded. It's useful there. We've had a few metrics of these in the past where you can see some of the page loading and some of them that wait for the full page to load. But the truth is, whenever you get in this largest bit, that's usually a sign for the users that they can start reading the article or looking at the shopping experience or whatever. And there may be other stuff, ads and stuff like that loading in later, but the largest contentful paint is normally a sign to the user that the page is now all pretty much there. FID, or first input delay, is our interactivity metric. It measures how responsive the page is. So if you click on a hamburger menu on your mobile phone, does the menu open, or does it take a couple of seconds to open? And then you click on it again out of frustration, then it opens and closes really quickly because it registers those 2 clicks, but it just took a little while to do that. CLS, or cumulative layout shift, this is the one that measures content moving around. So it's quite often whenever you on social media and you read these top movies to see, and you click on that and it starts loading, and then ads are coming in, you lose your place whenever you started reading your article. It's really frustrating, annoying one. That's actually my favorite Core Web Vital for that reason, because I think this is the first time we've actually tried to quantify that as a problem and how to measure it, and it's a really irritating thing. Some people say it's not necessarily strictly a load metric, but it's interesting nonetheless because it's a user experience thing that is caused by slow loading content. It's quite annoying. So next I want to talk about some of the guiding principles that we have behind the Core Web Vitals. And we have 3 principles here, basically. The first is that we want these to apply to all pages. So there's some very specific user metrics that you might be interested in for your particular business or your particular site. So you might be interested in conversions or signups for a newsletter. And that is very important for your business, and you should be measuring those. But that's not the intent of the Core Web Vital, which is intended to measure user experience across the whole web. So we want metrics that apply equally to an e-commerce site and a blog post site. So we're going to be able to say these ones have good Core Web Vitals, these ones don't, rather than this one has great conversion rate, this one conversion doesn't really apply, and how we measure those conversion, it gets complicated and stuff like that. So the metrics that we've chosen there that I've explained there now can broadly be applied to all websites, and we can give a Core Web Vital score to all pages on the web that we measure based on those metrics. Next one that we talk about is that we want to directly measure user experience. There has been a lot of web performance metrics in the past that try and measure the technical details behind the scenes of how the page is loading, TTFB or your DOM content loaded, all these technical terms that us web performance people may love, but the user doesn't get. The aim of the Core Web Vitals is that we're measuring actually what users are experiencing. And the easiest way to think about this is, can you explain it to a non-technical user? So I can explain to my dad the concept of the largest Contentful Paint. I can explain the concept of how much delay there is whenever you click on a button before something happens. I can explain that shifty thing. I maybe can't explain the whole calculations that go on behind that, but he can get that despite not being a technical person and understand why we're measuring that, rather than necessarily, you know, what time the browser thought something has happened. It's what time the user thought something happened that's more important. And then the last one, and we're going to spend a lot of time talking about this today, is that all the Core Web Vitals are 1, measurable in the field, and 2, actually measured in the field. And that's a very important concept with Core Web Vitals, is we are not measuring what Googlebot says or what Lighthouse says. We're actually measuring what the user says. So yeah, as I say, Core Web Vitals are not measured on a lab tool like Google Lighthouse. You will see a lot of people boasting about their Lighthouse scores. And trust me, I work on part of the team that creates Lighthouse. We're very happy with Lighthouse. We think it's good. But we think that's more a diagnostic metric, and it's an estimate of what your experience might be like, whereas the Core Web Vitals are measuring what they're actually like. And to do that, they're measured from real users of Chrome that opt in. So whenever you install Chrome, you're asked if you're happy sending anonymous data back to Google, and that's what drives the engine behind this. And that feeds back to a thing called the Chrome User Experience Report, where we collect all these metrics and load speeds, and then we can gather them up together, and we can say for this URL, 20 of the people had a fast experience and 40 of the people had a slow experience. Because web performance is not a single number. Web performance is a distribution. You may, if you've got 20 or 40 users as shown in this chart, some of them will have super fast connections and super fast devices on the, the latest Android phone. Some of them will be on a train in the middle of nowhere with very low connection. So the same web page may be performing quite differently for these different users. So there is no one number of this page is 46.2% fast. What you're going to do is you're going to get this range. And what the Core Web Vitals does is it tries to look at the majority of these users. We actually look at the 75th percentile and say that's roughly what 75% of your users are experiencing or better. And that's what we're using to measure the experience of that page. So as I mentioned, we measure this through a tool that we call the Chrome User Experience Report, or CRUX. And what it does is it collects all these data, tries to gather them up together. we're very conscious that there may be commercial sensitivities around this sort of stuff, and also there needs to be a comfort level that what we're recording and showing here is actually statistically relevant. So what we do is we only release this data for URLs that make a certain threshold. You won't be able to get crux data for every site and every URL. You'll only be able to get ones that pass that. So it really should be thought of as a high-level summary of what your performance is, because it is a public data set. It is limited to certain URLs, and there is a lot of good data in there, but it's aggregated at high level, and there is definitely no real place to put diagnostic data in there to help you debug. Because you need to realize that every user is unique. As I said, different users, different connection speeds, different devices, so screen sizes will be different CPU speeds. A lot of people are on older Android devices. Some people are on the latest and greatest super fast ones. A lot of people are on older machines that are only 1 pixel density, whereas the latest smartphones are often 3x density. Even if the devices are the exact same, users are coming to your web pages from very different places. They may be a regular visitor to your site, have a lot of the resources cached, you know, your common logo, your JavaScript, your styles are all there, and it's just loading one page. Or it may be completely cold load. This is the first time they visited your website, and it takes a little bit longer to show. Cookie consent banners are a big bane of the website, of the web at the moment. But those are things that different people will see. So again, regular visitors have probably accepted or rejected that banner and don't see it. New users will certainly see that. And we see an awful lot of people where that cookie consent banner suddenly becomes your LCP element. And it is definitely got a hugely different performance characteristics than your page load, because you know, it may need to load a third-party CNP and take a little bit longer to show that. You may actually, from a user experience, delay that show and say, here's the page, and then I'll wait 2 or 3 seconds, and then I'll interrupt the user with the cookie consent banner. But if that's your LCP element, then suddenly you're being seen as being slow because of that. Logged in or logged out users are all quite different, and users can be presented different content. I'll show a couple of examples of these next. So this is an article for web.dev. It's the website that I help manage to contains a lot of the core Web Vitals data. Here we have the exact same page loading on the left from someone who's already dealt with the cookie consent banner. Their LCP element is the title here, is the H1. And then on the right, you can see someone with the cookie consent banner. That's quite a lot of text in there. And you can see that the dimension of that is much bigger than the headline banner. Therefore, it usurps or takes over, it becomes your LCP element. So understanding what your LCP element is very important in understanding how you optimize it, because there's very different techniques for how you would optimize these 2 different elements. Moving on, the next example is from Amazon, and I've just picked this at random. I'm not affiliated with Amazon at all, but on the left, I'm logged in. You can see my name up on the top. You can see buy it again. I recently bought printer cartridges for my Canon printer, so it's offering that image for me to buy it. On the right, it's pretty much the same page, but you're getting different images there. So it could be that the save resources by used image as a second image in that bottom carousel is pre-cached, ready loaded there, because lots of people are seeing it, whereas not a lot of people buy Canon cartridges, so that one isn't cached. So it takes me a little bit longer for my Amazon page to show. And again, that's very difficult to replicate in a lab-based tool or even on your own desktop, because you'll see your content rather than my content. So moving on, I like to say that Crux is a good high-level overview. And again, I work on the product. It's a very good product, and I'm a big fan of it. But to me, that shows you have a problem. And it's surfaced in various tools, you know, PageSpeed Insight and your Chrome, your Google Search Console, and various other tools make use of it. So it's not the greatest at actually identifying what the problem is. It can say you've got an LCP problem, and maybe that's an easy one to solve and you can do it, but maybe not. You can then plug it into a lab-based tool like PageSpeed Insights or Lighthouse, or just looking around it in your own dev tools in Chrome. And that will certainly show a potential reason for that. So it might show this image is slow to load, and you know, oh yes, we've been meaning to improve our images and how they load, so I can go ahead and fix that, and that will maybe fix it for everything else. But what RUM can show is the actual problem. It can say it wasn't an image at all, it was a cookie banner. And that's a completely different optimization that you need to think and look there. And how you do that, maybe, as I say, you're comfortable with the cookie banner showing later, and that shouldn't be the LCP image, and you just need to nudge Chrome along to pick a better LCP image that's more representative of what the page is. But until you know that, you can be spending time looking at the wrong issue and trying to fix the wrong issue. So to debug Core Web Vitals, it isn't as easy as plugging it into a tool and automatically telling you what the problem is and you going and then implementing this solution. Lighthouse and PageSpeed Insights are fantastic tools, and they will do their very best to explain what that is and give you ideas of what you can go ahead and fix it. But you really need to understand what the problem is. And to do that, you quite often need to know what the element was that was slow. What was your LCP element? What was your FID element that was clicked on that was slow? Because that will lead to the interaction that you need to fix. On your CLS, what is the content that's shifting around? Is it due to an ad, or is it just at the page load at the beginning of the page? It takes a while to do that. So you need data to understand why it's slow. Just having the Core Web Vitals score isn't enough. And my colleague Phil Walton wrote this post on debugging performance in the field, and we started showing how you could capture a lot of this information and feed it back to your analytics to actually do this sort of investigation. And we'll talk a little bit of that now. For example, to optimize your LCP, to pick one of the Web Vitals as an example, you can run a performance observer, and Chrome will emit these LCP events, and it will say the element that's in it. You can grab that and paste it to a console if you're just debugging locally, or you can send it back to an analytics service to do that. And you can grab more details about it. Okay, you know what the element was, what's the element name, what's the element class, the page that it was on, what time was it loaded. All this sort of attribution data is fantastic to gather. Now, to do that can take a little bit of expert knowledge and stuff like that. And that's where run providers like Blue Triangle can help and do that, because they've taken care of that for you, and this is happening automatically to the background. And I'll leave Blue Triangle to talk about it themselves, but the principle that we want to get here is collecting this data yourself means that you don't have any of the anonymity requirements that we have to put in Crux, and you can collect a lot more interesting data to help you identify these problems and therefore lead on to fixing them. And continuing on with LCP, what we actually, what we did was a lot of analysis here, and we split the time. So LCP is the time that it takes to show that largest element there. And as well as knowing what the element is that's being drawn there and what page it's on, we actually broke it down, and we recommend other people do this too, of 4 phases. And there's different optimization techniques for each phase. So the first phase is time to first byte. That's how long it takes to get your initial HTML down before you even go in to fetch that LCP image or whatever it is. Until you got that, the page can't render. So that's your first bottleneck, as it was. And that is going to take time. That is the nature of web browsing. But understanding how much of that time is your problem means that you might go, okay, I don't need to optimize anything in the front end and how the page loads. I need to look at my back end and how the page is generated, or implement a CDN or whatever ways you need to optimize that. The next phase is the resource load delay. So you've got your HTML there. Are you immediately finding this, let's say it's an LCP image, and requesting that? Or is the LCP not in the HTML and you're a client-side rendered JavaScript app, so you need to get some more JavaScript, download that, parse it, compile it, execute it, and then go, oh, right, okay, now I need to get this image, and then get it. So that delay is good to know and understand, what can we do to reduce that? The third thing is, okay, we now know we need to get the resource. How long does it take to load? Is the image too big? Is it not cached at the edge node? Is it in the wrong format? And a better format would do that. And that's where we've traditionally spent a lot of time for image formats to look at, for image optimizations, as we've said, try and get the image small to download it. But we've actually discovered that this isn't a big part of it. It's actually the first, second, and sometimes even the fourth area that can be slow, and we kind of miss those. So until you got this attribution data of understanding these 4 sections, you can spend time looking at the wrong thing. And the last thing is the render delay. So you've downloaded your image, the browser's got it. When does it display it to screen? Because if you're sitting there and fetching it right as soon as the HTML got there, but again, it needs some JavaScript until it actually shows it, making the image download any faster, if your JavaScript is slow, isn't going to help things there. And we recently published some recommendations on how to improve your Core Web Vitals. And as I say, we're spending a lot of time looking at 1, 2, and 4, and less so at 3, which was the traditional thing of optimizing your image. And that's directly led out of the research of investigating where the delays are, rather than just assuming, oh, an image is slow to load, it must be the image format itself. So field attribution data really helps you to understand your Core Web Vitals data. It really does help you to spend the right time fixing the right issues, rather than guessing what the issues might be, releasing it, seeing that your Lighthouse's score has gone from 92 to 93, yay, but doesn't make a real difference, and then you put it in the field and spend time going through a release process and don't see that. So it makes fixing issues faster because you've got the real data to do it. And that ultimately means that fixing issues are cheaper because you're not spending developer resources looking at the wrong thing. So for the Core Web Vitals attribution, the LCP, I've gone through that in detail here. What we really recommend is finding the element and those 4 breakdown categories, because that can help you identify where your optimizations is. CLS, again, we recommend noting all the elements that shifted. Now, a point to note here is that these are often what I like to call the victims. These are the elements that are shifted, not necessarily which caused the shift. So if you're inserting a new ad that wasn't on the page before and all the content beneath that is moved down, the ad is the problem. You know, you'll quite often get the elements that move down because they're the ones that experience the shift because of this ad. But usually it's enough to point you in the right direction, so you can see where in the page this element is and what's loaded above it, and actually see what's down that. For FID or IMP, the responsive metrics, the element that was clicked on or where the interaction started and the time that it does that. And we're at the moment spending a lot of time in Google trying to work on a breakdown similar to the LCP breakdown there of how we can show what the time was spent there. Was it waiting on the main thread to be free? Was it actually executing on the main thread, or was it then painting the results of that execution afterwards, and it just took a long time? So we haven't quite got there yet. I don't know if Blue Triangle have done any more work on this, but we're certainly working on that, and we'll be publishing our results of that and encouraging RUM providers to implement that. And ideally, this needs to be per page and with various forms of aggregation. So you want to be able to sit there and look at all your product pages, for example, and aggregating them up and seeing, okay, the main product image is the time that's taken a while, rather than looking at each product page individually and seeing the same thing over and over again. It's much better if your data can be sliced and diced in the way that you can see that. And as I say, Crux unfortunately doesn't allow you to do that. You may have a busy enough site that you can get a lot of URLs there and you can gather that data and split them out separately and see that your product pages are fast, but your blog pages are slow. But that's kind of the level you get there. And anything beyond that, you kind of have to collect the data yourself. And then a final point I want to make is that your Crux and RUM may be different. I'm talking here about how you should collect this extra data through RUM or real user monitoring. When you've 2 sources of data, there's a famous adage that a man with a watch knows the time, a man with 2 watches is never quite sure, because they will be different, and it causes a lot of confusion there. There's a lot of data that might not be gathered in Crux because it's only Chrome users and it's only people that opt in to do that. There's a 28-day aggregation cycle where you can get a lot faster data in RUM and things like that. So I've written a post here on why the data might be different and why that's okay. As long as you understand that, and as long as they're broadly in line. I mean, if one's showing you've got a problem and the other showing you've got no problem, then that's obviously a bigger thing. But if one's showing you've a 2.5 millisecond, 2.5 second LCP and the other one's showing 2.3, don't worry about it too much. They're broadly showing you the same problem or lack of. So don't fret too much about them being, completely on sync. And there's things in this post about how you can ensure that data is more aligned. But in general, you're going to notice differences, and don't panic about that. And I think that's all I've got to say on that. So thank you very much for listening to that. As I say, this is more a general thing on the Core Web Vitals and how they work. I'm going to hand over to Blue Triangle to explain their solution to some of the problems I've given up here and how they fit in there. We do a lot of work with the RUM providers and Blue Triangle included, and I, for one, am quite excited about what they've put into their product and how it will help you guys be able to improve your Core Web Vitals. Thank you very much.
Thank you, Barry. So I'm going to be talking about a new feature Blue Triangle has released called VitalScope for Core Web Vitals. And I'll also give you a demo of how you can use it to quickly and easily understand what is causing your Core Web Vital scores to be what they are. Before we lift the lid on the strange and mysterious world of Core Web Vital drivers, let's take a minute to talk about how to identify if you have an issue that needs solving in the first place. How do you monitor the scores? So, as Barry mentioned, you can use the Chrome User Experience Report, or CRUX data, to understand how Google views your Core Web Vitals. But this is for a very specific data set, namely a 28-day summary of users that have opted into sharing data, and it's only available on a per URL or origin basis. And as a result, there are limitations to the questions you can get answered from this data. For example, let's say you push out a new template for your product pages in a hope that it's going to have a positive impact on CLS. And within the first few days, you want to see if it's moving the needle. Or you want to understand if your LCP scores are affected based on the country that the user viewing the page is in, or the browser they're using. Unfortunately, you can't get these questions answered with Google CRUX. But since Blue Triangle is capturing your Core Web Vital metrics for every single user page view, along with a myriad of other metrics, you can use our portal to trend the Core Web Vital scores. Here's a couple of screenshots of a couple of places that you can do so. The Executive KPI report that gives you a summary over the last 8-week period, and also the performance budget screen. And you can see here the filters and the level of control you have for trending your Core Web Vital scores. You can do it based on date, based on device, browser, based on the country, the page name. You can change the statistical method. There are also options based on your internet service provider, campaign codes, etc. However, this is only going to tell you if you have a challenge to solve, but in order to solve the issue, having the Core Web Vital scores is not enough. What we need is an understanding of all the factors and variables at play that cause the Core Web Vital scores to be what they are for all the different type of templates we have on our website. And crucially, we need that information for real users, not just for some synthetic or lab-based tools. We need to know what our users are experiencing. How do you get that data? Well, it's for that reason that Blue Triangle created VitalScope. In essence, VitalScope does two things, and it does it really, really well. The first is it collects all the attribution and all the debug data that Barry spoke about during his presentation. And we get it for every measurement. So we not only know the Core Web Vital score, but everything there is to know about those Core Web Vital events for each user experience. What was the image that resulted in the largest Contentful Paint? What widget on the page did a user click on that triggered the first input delay? And when in the page load did it happen? What element was the worst offender for moving around the page and giving a user a poor CLS? VitalScope captures all this information and more. The second is it makes the data actionable. Having data is great, but you need to be able to aggregate, filter, and trend it in a way that provides insight into the problem. VitalScope gives you extensive options for trending, so you can ask any question you want of the data and get answers back. Not only does VitalScope quickly and easily identify the cause of Core Web Vital challenges on your site, but it also gives you understanding of the business impact of these challenges, be it lost revenue, reduced returning visitors, or increased abandonment on key stages in your user journey. When you combine VitalScope with Blue Triangle's business analytics, it allows you to prioritize those issues that will move the needle for you the most in your business. I'll give an example of the type of impact that VitalScope can have on business decisions. Back in March, when we were developing the feature, we deployed a pre-release to one of our friendly e-commerce customers in the UK. This customer was just about to start a vendor selection process to find a new image optimization platform with the goal of trying to compress their images, which they thought was the cause of their declining and worsening LCP scores. After 1 week with VitalScope deployed, they could see that the size of the image and the format was nothing to do with their LCP problem, and it was in fact to do with how long it was taking to request the LCP image on the page. It was poor resource load delay. Now, as a result of this, they not only know how to fix their worsening LCP scores, but they've avoided the time and the expense of bringing on a new image optimization platform that wouldn't have solved the issue anyway. VitalScope enables you to stop guessing what the problem is and start knowing. So I'm sure by now you can tell I'm very excited about the functionality and opportunity that VitalScope brings to our customers. But you don't have to take my word for it. Here's a quote that we received from our friends at Google when we first shared VitalScope with them. And Blue Triangle is very excited to get such amazing feedback and validation from the company that not only invented the metric, but also champions and spearheads their adoption within the industry. And with that, let's move on to a demo of what VitalScope actually is. I'm going to start with the new data you get to play with for LCP as part of VitalScope. So as we're capturing this data for every single page view in a session, you can go off and look at the raw and aggregated VitalScope data using tools such as the session scatter plot in real user performance details, as you can see in this animation. The first bit of data we're capturing is the LCP element, and that is the thing on the page that had to render before an LCP metric can be reported. VitalScope gives you 3 pieces of data about the LCP element, and those are the URL, the actual HTML from the page, and the DOM selector of the element. This is super, super cool and insightful. For every user that has an LCP event, we can go and see the image on the page that was driving the experience. You can take the URL, paste it in a browser, and actually look at the image. You might be surprised to find which image it was. Or you can use the HTML or the selector to go off and actually find the code in the page using Chrome DevTools or some other development environment. And you can do this for every measurement. Now you might ask yourself, why do you need anything other than the image URL? But what if LCP wasn't triggered by an image? In one of Barry's examples, he showed the web dev website on a mobile device for a user that accepted cookies. And for that user, the LCP event was a text element. There was no image URL. So this is why we capture the HTML and the DOM selector, so you can identify what drove LCP, regardless of whether there's an image or not. The other information we're capturing for LCP are the 4 subparts, or phases. In this screenshot, we're capturing those percentages of the overall LCP metric. So if for this page view, the LCP score was 5 seconds, we can see that time to first byte took roughly 2.5 of those 5 seconds, whereas resource load delay, the time it took to actually request the LCP image, took roughly 750 milliseconds. If you'd rather have the data represented as those absolute millisecond values, we can store it in that way too. Or you can actually have both. It's completely configurable. And of course, we can trend these over time using whatever filters you want to look for behaviors and patterns in the subpart data. Now, I can honestly say, for those of my customers that have already had a pre-release access to VitalScope, that this data has been a revelation to them, and it's dispelled a number of assumptions that they had around the cause of their poor LCP scores, one of which normally being what image it is actually on the page that was driving LCP to begin with. Moving on to cumulative layout shift. The main focus here is in capturing information on the largest shifting element. Now remember that there will often be multiple elements on your page that shift position during loading, but VitalScope reports back the identity of the element that is causing you the biggest problem, along with the time on the page load that it started moving. Also remember, as Barry said, that this element is often the victim of something else loading in, as opposed to the actual cause of the problem. Fixing CLS is an iterative process. Once you've addressed these issues that are causing a larger shifting element, the next highest offending element will bubble up to the top and start being reported on, and so on. However, you don't have to wait until that happens to have insight into how many CLS issues exist on the page, as VitalScope also reports back a log of all the CLS session windows during the page load. For those unaware, a CLS session window is a grouping of all the elements that shifted during a 5-second interval, and just like there can be many elements that shift, there can be many CLS session windows in a page load. Having visibility of these gives further insight as to whether there are further significant CLS issues to resolve on a page once the largest shifting element has been dealt with. In the example here, we can see that the CLS element belongs to shift window number 1, as that window has the highest overall CLS value. But there are also significant issues in shift window 2. As we can see here, this is a CLS score over double the actual target of 0.1, and that there's only also one element moving in that shift window. So there's one element in that shift window that has a CLS score of 0.237. Finally, let's look at first input delay. For FID, we are capturing the element that user interacted with first on the page, along with the time in the page load that interaction occurred. Again, we capture selectors as well as the HTML element for reasons that will become clear when we go through a worked example. We also capture some additional information for FID, such as the interaction type, but that is exposed elsewhere, which brings us on to the new data filters you get with VitalScope. I've shamelessly stole one of Barry's slides here to remind everyone of the target threshold set by Google for the Core Web Vitals, or the Core Web Vital traffic lights, as I like to call them, for reasons that will become apparent. At the start of my presentation, I said that you need to be able to trend, aggregate, and filter data to make it actionable. And one of the ways that this proves very, very useful is in identifying the problem area. So, for example, let's say you're investigating an issue with your CLS metric being in the red, so it's above 0.25. It would be good to be able to isolate just those measurements and those experiences that your customers are having that fall into this problem area, i.e. just those users that get a score of 0.25 or higher for CLS. Any measurement with a score lower than this is not actually contributing to your problem, And it also makes it harder to spot the cause of issues if you include that in trended data, as it introduces good, clean data points into the mix and bring overall averages down. To facilitate this sort of analysis, we introduced the Core Web Vital traffic light filter, which tags every page with a good, needs improvement, or poor rating for each of the Web Vitals based on Google's thresholds. Now we're investigating your vital issues, you can focus on just the problem data points. Or alternatively, if you want to be more positive, you could just focus on the successes. And of course, these could be used in conjunction with any of our pre-existing filter options. As we'll see in a couple of slides, being able to filter based on this overall rating makes it so easy to quickly find the issues within your Core Web Vitals. The other filter option we've introduced with VitalScope is called Debug Details, which provides more granular data for LCP and FID. On this slide, we have a couple of screenshots from web.dev to help explain the power of debug details. On the left, we have a table showing target percentages for the LCP subparts. As Barry explained in his section, LCP is made up of phases that are split between network activity and page activity. If a user experience falls above the target LCP of 2.5 seconds, Google recommends looking at how much time is being spent in each of these subparts or phases. And it also provides guidance on what percentage of the overall LCP score should be spent in each of these subparts, namely 40% for time to first byte, 10% for resource load delay, 40% for resource load time, and 10% for element render delay. On the right of the slide, we have advice on how to debug first input delay, with the summary being that poor FID can often be a result of necessary JavaScript resources not having downloaded at the time the first interaction occurs. It is therefore important to know and to be able to trend when in the page load FID actually happened. The FID action, in conjunction with the FID element discussed earlier, is also useful to identify if there is an element on the page that should possibly be disabled or displayed later in the page load to avoid user interacting with it too soon and experiencing a poor FID. Or alternatively, whether you should inject JavaScript inline into that element to make the page more responsive and not wait for the download of a resource. The Debug Details filter captures all of this information for every single user experience and page view. In much the same way you can filter on the Core Web Vital traffic lights, you can also filter based on how the LCP subpart measures up to the recommended thresholds. For example, only show failed element render delay page views, where render delay is greater than the 10% of the LCP score. Similarly, you can also filter where FID occurred before DOM content loaded or window loaded, to get an idea of what users are actually triggering first interactions before you've downloaded your JavaScript resources. Or show page views where the FID action was a key press versus a mouse click to see if it's one interaction or action type has a worse FID than another. When you combine the traffic light and debug filters together, you can identify specific issues with incredible speed. Now I'd like to walk you through an actual real example of VitalScope in action, debugging an LCP issue for an e-commerce PDP page. Now I've chosen a PDP page because I wanted to make things difficult to show the power of VitalScope. If I'd picked a home page or a contact us or something that had a limited number of actual live pages on the site, then that limits the number of URLs and elements that could be driving LCP and makes it an easier problem to solve. But for a PDP page, there can literally be thousands of URLs and images that could be driving the LCP experience, which creates a bit more of a challenge. So what are we looking at here? This chart is showing a trend of the LCP subpart for all the PDP pages over a 24-hour period for desktop devices. Now, I already know that the issue is that the 75th percentile for LCP is above the 2.5 seconds guidance. So I'm also employing the Core Web Vitals traffic light filter to only trend pages where LCP is poor or needs improvement. And doing so gives me a view of data that is just in my problem space. And I can quickly see the LCP score split between the subparts for the failing measurements, and two jump out. Time to first byte, which should be around 40%, but is actually at 48%, which is about 1.2x what the target is. But the biggest concern is resource load delay, which should be around 10%, but is more than double that. So in less than a minute and with a couple of clicks, I know that the most likely cause of the poor LCP experience for desktop PDP pages is that the LCP element is being requested too late in the page load, or put another way, other resources are being prioritized over that LCP element. The next step is to identify which LCP elements are causing the biggest issues so I can get them fixed as a priority and start moving the needle. What I want to do is to identify offending LCP URLs and then trend them in aggregate waterfall so I can see when it's loading and what resources are being loaded before it. But because I've chosen a PDP page, this presents a bit of a challenge, and that challenge is illustrated here. The chart again filters based on desktop PDP pages for the last 24 hours with poor or needs improvement LCP measurements. But it's trending the LCP URLs rather than the subparts. Because we just found out that it's a resource load delay that is our issue, we can further filter our data using debug details to limit our data to just those measurements that have a load delay of over 10%, i.e. just filter on resource load delay fail. Unfortunately, because we're working with a PDP page, there are hundreds upon hundreds of URLs for these failed measurements that are coming back. And we can't tell which ones are actually representative of any common problems. Here we can see the top 5 URLs, and they account for only 4.5% of the total page hits in the dataset. As a result, we don't know if any of these URLs are representative of commonly occurring problems, or are outliers, or that if every product page has a unique LCP issue. And to explore this a bit more, let's go back to Barry's example with Amazon. So here we have 2 product pages loaded with different LCP URLs. We can clearly see that the page templates being used here are the same for both products. But because the URLs are different, if we looked at this in simply trended data, we wouldn't know that they're from the same template. And we definitely don't want to have to go through each of the URLs in our previous data set and compare them with the actual pages to try and identify commonality. We want to stop guessing and start knowing where the problem is with the PDP pages. And the answer are the selectors that we also capture for VitalScope. Here are the 2 Amazon pages again, but this time I'm showing the DOM selectors rather than the URLs, and we can see that both images share a common selector because they're using the same template. For those unfamiliar, selectors are a way of querying a HTML page to identify elements based on CSS and other attributes. Since most PDP pages on a site share a small set of templates, when we trend by selector, we can identify a higher level of aggregation of data. So let's go back to our previous charts, but instead of looking at URLs, let's look at selectors. And here's the data. So now we're trending selector rather than URL, but all other filter elements are the same. And in stark contrast with the URL view of the data, where the top results returned were less than 5% of our problem measurements, with selectors, the top results account for more than 95% of our problem measurements, with the number 1 selector accounting for over 2/3 of our problems. So now we've identified a pattern without having to go through the timely process of comparing individual URLs with pages to identify if there is some commonality. So all we have to do now is find the URL for each of these selectors, go off and remediate the issue, and we would expect that fix to apply to every single instance of the PD page that shares the same selector. So how do we identify those URLs? Well, there are some additional filters I didn't mention earlier, and those are selector filters. So once you know what selector that you want to look for, you can easily filter the data and find individual data points using these filters. And it's not only for LCP, we've also introduced them for CLS and FID. And this is super powerful to very, very quickly and effectively find the problem measurements that you will need to fix. And it doesn't stop with just identifying what the issue is for Core Web Vitals. When the time comes to actually fix and monitor to see if the fix is effective, Blue Triangle has a complete set of tools to help you. For time to first byte issues, we have network health check and base page monitors to make it easy to identify if the issue is in the last mile, with your CDN or network edge, or with your origin infrastructure. For resource load delay and resource load time issues, we have aggregate waterfalls that quickly and easily enable you to trend large volumes of real user data to identify where the LCP element is requested, and also domain trends and baseline analysis that you spot the worst offending assets that might be preventing the LCP element from being requested sooner. And then Blue Triangle's unique function tracing waterfalls help you easily identify long-running JavaScript functions that might be blocking the main thread from rendering an image on the page, even though it's downloaded in a timely fashion, and it's therefore causing element render delay. And it's not just about LCP. For CLS, we have synthetic film strips that make you easily visualize the largest shifting elements once you've identified it in your real user data, and also validate once you've applied a fix, so if actually the CLS issue has been resolved. And the same is true with first input delay. With our real browser synthetic scripts, you can actually script your first input delay in your test based on knowledge of what those first input delay events are that you gleaned from the real user data that were captured by VitalScope. And then again, easily validate that a fix has been effective. In order to prioritize which issues you need to fix, we have revenue opportunity and bounce and exit analysis that let you identify which issues are going to move the needle in terms of your business objectives the most. And then when it comes to validating the changes, as we've seen on earlier slides, Blue Triangle makes it easy to monitor in real time changes to your Core Web Vital scores once you push fixes out to the field. That brings us to the end of the overview and demonstration of Blue Triangle's new VitalScope functionality. I hope this has been useful. I have to admit I'm very excited to see how our customers put this functionality to use, and I'm also especially interested to hear of any success stories that customers have of putting to bed any long-running Core Web Vital issues they've had by utilizing this functionality. A couple of quick key takeaways from what we discussed. Remember, you need more than just the scores in order to identify where your Core Web Vital issues are. You need the attribution data, but that data needs to be actionable and it needs to be from RUM. You need to capture it for your real users to understand where the problems are. And don't forget that the Core Web Vitals have real, genuine business impact. They're not vanity metrics. Everyone knows that they influence your SEO rankings, but more than that, they are measures of your user experience on the site. So if you have a poor Core Web Vital, then that will reflect itself in user behavior on your site, be that page views, retention, or conversions. If you'd like any more information about anything I've discussed today, or you'd like to have VitalScope configured on your account, please contact your Blue Triangle customer success team or your SE, and they'll be happy to help. And with that, it's back to you, Nick.
Awesome. Thank you, Kerrion. Really appreciate it. That was fantastic, honestly. Barry, great job helping us out and setting the stage. Kerrion, great job going through the Blue Triangle vision of it and what VitalScope can actually do for our customers. Really, really excited about that, and see the excitement flowing through chat right now too. Meredith and Irene, thank you so much. We are super, super excited about this as well. This has been one of our really cool things that we've been working on over the past few months, and obviously we got some excitement from Google too. So it's been really cool. So we're going to go ahead and jump into the Q&A segment. A few questions have come through already that we can kind of discuss. And feel free to keep adding questions and we can kind of talk about it. Bala, I'm going to go ahead and address yours first. But that was, let me scroll up and read it. Let's see. Is VitalScope available for all existing customers? And Kerrion kind of tapped on it at the end there. But yes, VitalScope is available. And I apologize for the dogs. VitalScope is available for all current customers. Just contact your customer success organization to be able to instrument it. Are the dogs very loud? Kerrion, can you tell me?
They've gone.
All right, great. Apologies for that. I was going to go on mute and let you take over, but that's a relatively simple answer. Contact your customer success team, and then we can talk through that and figure out how to instrument it real quick for you. And if you want to talk to either Kerrion or myself, we can also instrument as well. Kerrion it generally works in the EU, and then I generally work in the United States, and we can work through that. So next question, and we still have some coming in. Let's see. Is there an extension in Chrome, in our Chrome browser for this? Thank you very much. And so, Kerrion, I will let you take that.
Thank you, Nick. So the answer is at the moment, sort of that Blue Triangle doesn't offer actually an extension to give you this information yet. But we are, I don't know if I'm letting the cat out of the bag, but we hopefully intend to release during this quarter an extension that will allow you from within your Chrome browser pull your Core Web Vital scores, not for your page load, but for your entire users. So you can actually, sort of decide, go and have a look how your experience compared to all your mobile users for this page. And the information will be at, so aggregated at a page level or a URL version, and will provide you with quick links to get straight into the portal. So it may, I don't know who the question came from, sorry, but it may not actually give you every piece of data that you want that we talked about today, but it will give you the Core Web Vitals and provide you with quick and easy access from the extension into our portal to get that information. I hope that answers the question. Please put in the chat if you didn't.
If I could just interrupt there, we also have an extension as well that does show you your data, but not the RUM data there. And it also, in the next version, which isn't released yet, Blue Triangle have beaten us, it will have these breakdowns that Kerrion's talked about there. So again, this is what we're recommending is the way of doing it. So if you want to reproduce something that Blue Triangle's shown locally, and you want to see those breakdowns and see whether you've improved that 22% resource discovery time and moved it down to 10%, there is a Chrome extension for that.
Awesome. That's fantastic. And the next question that we're going to get into, this one's directed at Barry, and I think Kerrion will also have some comments. But Barry, do you have any suggestions on how to figure out CLS from RUM data? In my head, RUM data indicates a problem, and synthetic will help identify the problem, which is the opposite of what you had in your deck. How do I know what elements shift on my user's display without a film strip?
So I think Kerrion showed there is a film strip, but I'll let him talk about that in a minute. Yes, in some ways, particularly load CLS, it's quite simple. You can just use a synthetic tool like Lighthouse, run it, and it will tell you exactly what things are shifted, or you can just run it yourself with your dev tools open and notice it. And those are the very easy CLS issues to resolve. What's much trickier is if you have a post-load CLS issue. And I literally just published a post on this yesterday on the updated the optimized CLS guide. If you have a CLS issue that you cannot figure out, and you're loading the page and you don't see any CLS and everything looks fine, but you're getting bad CLS scores in both your RUM and in Crux, those are the really frustrating ones that you don't know what's happening. And it could be, it's usually due to an interaction. Someone's scrolling down, you've got one image that doesn't have height and widths identified or whatever. So those are the things where your RUM attribution, as I call it, can really help, because it can tell you the element that shifted. So let's say, for example, you have a login button that launches a modal and it's not very well optimized and it's moving the elements around. If you don't hit that login button while you're trying to debug it, you're never going to figure it out. And you're wasting time looking at the images, looking at everything else and going, I can't figure this out. Whereas hopefully the RUM attribution will say, it's the login welcome text element that's moving down. And then it immediately goes, okay. That tells me where to go and have a look for it and do that. So yes, for load CLS, this maybe isn't necessary, but for all those other difficult to find ones, it's invaluable to get that quickly. Kerrion, I don't know if you've got anything else to say there.
Yeah, I think you covered most of it actually, Barry. Thank you. But I will tag onto the end to it and just sort of riff a little bit on what you were saying. And it is actually sort of RUM data is about identifying the problem. I completely agree with Lauren's comments about using synthetic tools, one of which can be Blue Triangle synthetics and the film strips, to actually try and help you see the CLS image shifting, and also to test that any remediation has fixed it. But you need to know what are the biggest issues that are actually impacting the largest cohort of your users, and that's where you need the RUM attribution data. So I was going through a customer on a call with a customer about on a call today, where we were actually trending in similar graphs I showed for LCP for all failed CLS metrics, the selectors, so we can see which selectors were most common, and we could see that it was skewed 35% for one selector, 14% for another, and then everything else was multiples of 1 or 2, etc. So now you've identified the two biggest problems that are going to move the needle, so that you're not spending a lot of time within a synthetic or within Lighthouse, etc., fixing an issue that impacts a very, very small segment of your users.
Awesome. Thank you both. So as we continue through these questions, there's a lot of them coming through, so I apologize if we can't get to every single one of them. But let's see. In a high-level sentence or two, could you summarize what one could do with VitalScope that he or she cannot do with the Blue Triangle platform prior to VitalScope? Also, would it replace existing functionalities? Kerrion, I think we'll start with you on that.
Thank you, Nick. No, it doesn't replace existing functionalities, it extends them. And the slide at the end where I talked about the other areas of the portal that sort of complement VitalScope to actually fix the issues, will still be required. What's new about this that you couldn't do previously with the Blue Triangle platform is the attribution data, actually knowing what's happening for these Core Web Vital events with your customers and with your users. So previously we were just trending the metrics themselves, so we could identify that there's a problem. And actually some of the stuff that we talked about today, you could do with the platform, but you had to do a lot more digging. So you can now do literally in minutes what could have taken hours previously. So by having the data to say, these are the elements, these are the URLs, these are the selectors, these are the HTML elements that are causing you a problem, and being able to filter and trend them easily. So you're just focusing on those that are causing you a problem. You could do some of this before, but it was a bit more work to get to the data in the portal.
Great, thank you. And the next question is, outside of contract and cost implications, are there configuration things we need to do to make use of this? I'm just going to go ahead and take this one. This is definitely where you need to work with your CS organization to be able to instrument it. As of now, there is no cost implication to be able to turn this online. It's a matter of being able to use a lot of our innovation going forward. Next one is VitalScope data exposed via API? Kerrion, do you want to take that?
Yeah, it's a simple answer that yes, we have a RESTful API, and like with most of our data, you can actually call it and put it out of the platform should you want to. And then also outside of an API, you can do all the standard ways of extracting data out of VitalScope, like sort of exporting as a CSV, sort of exporting it as JSON. So you can actually go into the portal and actually see the queries to get some of the data.
All right, and then the last question we have, and I'm actually very curious of Barry's answer on this because this is a different Google originated metric, but can any of this be used to troubleshoot total blocking time?
So TBT, total blocking time, is an interesting one. We generally use that in lab data to try and indicate there may be a problem with your responsiveness for your FID or your IMP. TBT by itself isn't a problem. If the main thread is busy and the user isn't clicking anything, who cares? But because there's no interaction whenever you run a Lighthouse report or a web page test or those sorts of things, we kind of look and measure the amount of JavaScript and saying, hey, there's a lot going on in JavaScript. There's a good chance that people are going to be clicking here. You want to look at that. So we much more recommend looking at the actual interactions rather than the potentially blocked interactions. As I say, TBT is more hey, well, we've got nothing better there without simulating a lot of interactions. That's what we're going to use there. So FID is our current responsive metric. We're also looking at another one, IMP. That's, I don't know, Blue Triangle will talk about what their plans are for that, which will show a lot more of the interactions rather than FID is just the first input delay. So it's only the first and only input delay, whereas IMP looks across all your interactions and kind of picks the worst one in a similar manner to CLS. And again, we think those are better metrics of this actually caused a problem rather than you blocked the main thread for a long time. Maybe it caused a problem, maybe it didn't.
And if it's just coming to the end of Barry there, talking specifically about first input delay, I think there'll be a future training session at some point about what we're doing with IMP. But the attribution data that we're collecting allows you to very easily find trends and like sort of patterns as to what users are interacting with first to spot the problem, similar to what we talked about with CLS, similar to what we talked about LCP. Once you've got that, very easy with Blue Triangle to script a synthetic that reproduces those main offending first input delays, not only so that you can see them in repeated tests, but to very easily then see if your fixes are actually working. So using both the synthetic and the RUM data is a big part of using VitalScope.
Fantastic. And I'm going to go ahead and do one more question, but I totally understand if everyone has already had to drop off for another call. It's right at the hour. So the last question, then we'll go ahead and close up. And that is, you mentioned that VitalScope can be customized. What sort of customizations are possible, Kerrion?
That's a great question, Nick, because that plays to sort of innovation and also like one of my favorite phrases, which is the art of the possible. So Barry talked about getting this attribution data out of a performance observer of the page, which is in essence what Blue Triangle is doing to basically beacon the data back. Therefore, we can tailor it to specific customers if there's additional data that I haven't shown in the presentation that as part of the standard product. So what do I mean? Let me give you an example. We're currently only capturing the highest shifting element for CLS. So that, and this is based on some of Google's guidance in terms of how to debug CLS, deal with the biggest issue first, and then the next one will bubble up to the top. What if you don't want to wait? Or what if, as per my example, you know that there's already another shifting element that also is already blowing your CLS score? Well, we could configure VitalScope to capture the second CLS as well as the first, or the first three. You tell us what you want, and we can actually make those filterable attributes. Okay? Similarly, let's say you don't want to capture the HTML element for every single page because you're concerned, for example, that maybe on a checkout page that HTML image might, sort of give away some personalized information. Well, we can tailor VitalScope to say only capture HTML data for specific pages. So those are the sort of things we can do with customizations.
Yeah, absolutely. And so as we wrap up here, Barry, any final thoughts or final comments?
No, I will just say this is fantastic. I mean, I don't work for Blue Triangle, and I need to be careful that I don't use the Google name here to do this, but I've been moaning that run providers don't do enough of this sort of stuff for a while in our sync-up calls. I don't know whether you've been at the end of that that thing, but I haven't seen as good an implementation here in this and the other ones. I know some of them are working on it, but this does seem to be ahead of the game, and I'm very pleased to see that because we do honestly think it is a great source of information, and it can be frustrating debugging Core Web Vitals, and the more information you've got, the better. So yeah, I'm very pleased to see this, and I'll be really interested to see what your customers make of it, and whether it proves useful or if there's other things that they end up using it for, or some of those customizations, and if we should end up recommending those things too to other people. But looks great so far.
Awesome. And again, thank you so much for joining us, Barry. This has been really, really fantastic for everyone in attendance. We broke some records on the Blue Triangle side today. Very happy about that. Feel free to reach out to any of the three of us and on LinkedIn, in email, however it may be, and we'd be happy to continue the conversation with you. Again, thank you so much, everyone. We really, really, really appreciate it.
Thanks for having me, and good luck.
Thanks, Barry. Thanks, Nick.